The James Webb Space Telescope has been designed to answer many of the core questions that have animated astronomers over the past half-century. With a $10 billion price tag, it is one of the most ambitious engineering initiatives ever attempted. But for it to achieve its potential, nothing less than to write the history of the cosmos and reshape humanity's position within it. A lot of things have to work just right. Our galaxy, the Milky Way, has over 100,000 million stars. And based on data from NASA's New Horizons space probe, we now estimate that our universe contains roughly 200 billion galaxies. The universe is big and filled with mysteries. The James Webb Telescope is estimated to be 100 times more powerful than its predecessor, the Hubble telescope. In today's video, we'll share what scientists believe are the 5 most important discoveries that the James Webb Telescope is expected to make. Dark matter and dark energy are cosmic forces inferred by their influence on the universe. Dark matter is a mysterious, invisible form of matter that is thought to make up about 27% of the known universe, outweighing visible matter about 6 to 1. Still, despite making up a considerable chunk of the universe, it has eluded our understanding since its existence was first suggested in 1933 by Fritz Zwicky, a Swiss-American astronomer. To date, dark matter has never been directly detected. The James Webb Space Telescope could help to solve the pressing mysteries of dark matter. While the James Webb Space Telescope cannot directly see dark matter, scientists think that by measuring the effects it has on its surrounding, Webb could answer some major questions about dark matter. This in turn would greatly advance our knowledge of the universe at large. Planet 9, also referred to as Planet X, is a massive hypothetical object in an elliptical orbit far beyond Pluto, roughly at a distance that would take 10,000 to 20,000 Earth years for it to complete a single trip around the Sun. Although the planet is not discovered yet, the unexpected patterns in the orbits of other, smaller objects in the icy outer reaches of the solar system could be explained by the gravitational pull of this mysterious body. James Webb's telescope is powerful enough to discover Planet 9. Although the ground-based satellites on Earth could not detect it, the James Webb Telescope has all the equipment to discover and study this planet. A key reason behind James Webb Telescope's power is that it is primarily an infrared telescope, whereas Hubble is primarily a visible light telescope. Infrared is powerful because the oldest light in the universe is red-shifted into the infrared. This gives James Webb Telescope the ability to peer further and deeper into the universe, seeing objects that are impossible for Hubble to observe. For example, it will allow us to take pictures of the universe when it was just 100 million years old. Additionally, visible light can't pass through dust, but infrared can. So James Webb will enable us to see through obscured and dusty regions of space, such as stellar nebulae. Knowing when the first stars were formed, soon after the Big Bang, and understanding how they produced the building blocks of the first galaxies is an important scientific question, and one of the primary science goals of James Webb Telescope. We know that the elements that are needed for life in modern technology, such as carbon, silicon, and gold, were ultimately created in early stars, but we don't currently have a good understanding of how this happened. The need to detect faint objects in the distant universe has been an important driver for the design of the observatory, determining its size, wavelength coverage, and need to keep it very cool to minimize undesirable background light. Studying the first stars and galaxies is not the only scientific program James Webb will perform. It is conceived as a general-purpose observatory on which astronomers from around the world can apply for time to support their research. For example, observing in the infrared will allow James Webb Telescope to see through the clouds of dust that enshroud very young stars, which are opaque to visible light. Young stars emerge from the dustiest pockets where it's most challenging to see through. Thanks to Webb's high infrared sensitivity and spectacular resolution, scientists might be able to sift through the dust to make out these infant stars with unprecedented detail. And Webb might help scientists figure out how the dust cooks up a star, why stars form in clusters, and how planets form around a star. The Webb telescope should enable us to image the inside of these systems and capture protoplanet and protostar formation. Determining if our solar system is typical or atypical may also help us better understand our place in the universe. The first several hundred million years of the universe's existence are shrouded in mystery. Our models of how the first stars and galaxies formed, riding the condensation of dark matter halos, are lacking observational data to either confirm or falsify them. This is because the early universe is only visible in infrared, requiring a telescope of James Webb's scale to the image. Using data collected from these observations, we will be able to answer questions about how the first stars and galaxies formed in the universe, which will have profound implications for our cosmological models, especially regarding the great mystery of dark matter. Powerful lights called quasars are the brightest objects in the universe. Powered by supermassive black holes up to 1 trillion times the mass of our Sun, they outshine entire galaxies of billions of stars. Studies show that while even NASA's Hubble Space Telescope can't see galaxies currently hidden by these quasars, the James Webb Telescope will be able to get past the glare. James Webb will allow us to observe these very distant host galaxies for the first time. What do the first black holes look like? And why does every galaxy have a supermassive black hole at its center? Nothing can escape a black hole, not even light, so technically black holes are invisible. Luckily, swirling around black holes is plenty of stuff we can see: stars, dust, and entire galaxies. To study black holes, scientists scrutinize this stellar menagerie, similar to studying a shadow to learn about its shadow-casting object. Every galaxy is known to have a supermassive black hole at its center, but we are still unsure about how exactly these behemoths formed. Our current theories predict that the first stars may have collapsed to form these giants. However, we are not sure how they were able to get so big so quickly, forming the incredibly bright quasars that we can still observe over 13 billion years later. The James Webb Telescope should enable us to peer back and discover their origin story. Is there another planet like Earth? Can we detect life elsewhere, both in the solar system and beyond? When the first plans for James Webb Telescope were being discussed more than 20 years ago, no planets were known other than those in our own solar system. Since then, astronomers have discovered thousands of planets orbiting other stars in our galaxy. A significant fraction of the James Webb Telescope observing program will be devoted to the study of their atmospheres. The wavelength coverage of James Webb Telescope is particularly well-tuned to studying molecules in exoplanet atmospheres and the low infrared background from space, giving it a considerable advantage over Earth-based telescopes. James Webb Telescope will enable us to directly image large exoplanets and take spectroscopy readings of many more. This is important because it enables us to determine the chemical composition of exoplanet atmospheres. If some of these planets are harboring life, there could be possible biosignatures in the ratios of chemical elements that are different than what is geochemically normal. It's possible that we will detect these biosignatures of alien life, especially in systems like the nearby TRAPPIST-1. We can also do the same closer to home, turning James Webb Telescope on the moons of Titan and Europa. The telescope is powerful enough to directly image individual exoplanets orbiting distant stars, a tantalizing prospect that some say could lead to us finding out once and for all if we're alone in the universe or not. Greenhouse gases like CFC could be signs of extraterrestrial civilizations, since the same gases led to humanity punching a hole in the Earth's ozone layer, and a clear marker of industrialized civilization. In short, aliens who have polluted their atmosphere could provide a giveaway sign of extraterrestrial life. In addition to studying planets outside our solar system, James Webb Telescope will be able to observe our home planetary system. Its great sensitivity will enable the identification and characterization of comets and other icy bodies in the outermost regions of the solar system. In such a remote location, these objects are largely unchanged since their formation may contain clues to the origins of the Earth, particularly the source of its water, which may be the result of bombardment by such bodies early in its lifetime. James Webb Telescope will also be able to observe all the planets that lie outside the Earth's orbit of the Sun, studying their atmospheres and seasonal weather variations. What is the true rate of universal expansion? Recently, cosmologists have found discrepancies in different measurements of the rate of the universe's expansion. This discrepancy is known as the Hubble tension, and it stems from making measurements of the local galaxies and of the cosmic microwave background and comparing notes. But the precision of local measurements is notably obscured by dust, something that James Webb Telescope can address. With newer, more precise measurements, astronomers will learn whether this discrepancy indicates new physics, or is simply measurement error. The importance of the measurements coming from the James Webb for the fields of astronomy and physics can't be understated. James Webb Telescope has the potential to completely rewrite our understanding of the universe, from how galaxies and stars are formed to the structure of planetary systems. And that's not even mentioning the possible scientific inquiry into signs of alien or intelligent life. We truly are living during the most exciting time ever in human history. That's all time we have for today's video. Like this video if you found it helpful, and don't forget to press the bell icon so you won't miss any updates.